All right, we're going to take this just a page at a time, and we're looking just to get through this first page. Hopefully it won't take too long. We're going to show the relationship between the factors we get out of this function and the standard form of the equation. So if I get the zeros for this, all you do, if you look at this first function, it has 3 factors. You set the factors equal to 0. If you do that, and we solve each one of these, we get x equals -2, x equals 1, and x equals, well, if I subtract 3 from both sides, -3. These are called zeros, roots, or solutions. Let's go ahead and take that and put it in standard form. So, and then we'll do a comparative analysis between these two. So if I take all the factors, and I multiply, I'm going to assume you know how to FOIL this. If you FOIL these two together, you get x squared plus x minus 2. And then you multiply everything through here. Let's do it. X times x is x cubed. X times 3 is 3x squared. These two together make x squared. These two together make 3x. These two make -2x and -6. And when combining like terms, we get our final f of x cubed plus 4x squared plus x minus 6. Alright. Now if we come over here and do the same thing, well, these factors are a little bit different. They've got coefficients and constants. But we can do the same thing. We can set them equal to 0. I subtract 3. 2x equals -3 and divide by 2. There's one root. This would be add 5 divided by 4. And this would be add 1 divided by 6. We have our 3 roots. So, given this, if you FOIL this out, I'm going to give this one to you. If I multiply all those guys together here, I'm going to get this. I'm going to get 48x squared, which is x cubed actually. And you can see that 24 times 2 is 48. And the rest you'd have to work out. So we got plus 4x squared minus 92x plus 15. What I really want to focus on are these two numbers right here. And these two numbers right here. So, here's the question. It says, look at the relation between the zeros of each functions and the coefficients of its standard form functions. So, even though there's 4 coefficients here, if you count that constant, and 4 coefficients here, we're really going to only look at the first one and the last one. So if I look at the f function, f of x, right, my zeros are, let's put our zeros up here, are -2, 1, and -3. Well, if you look at this constant, -2, 1, and -3 are all factors of my constant, which is what we're going to write. They aren't our factors of anything else here, but my zeros, my roots, seem to be factors of that -6. So I'm going to write that. All zeros are factors of constant. And for g of x, you got something a little different. Here's our zeros. Let's write them. They're -3 over 2, 5/4, and 1/6. Well, -3, 5, and 1 are the numerators. And I don't see how 5 relates to 48, or 4, or 92, but 5 is a factor of 15. And if you look at it, so is -3. So for this one, numerators are factors of constant. Right? They're all factors of constant. And my denominators, 2, 4, and 6. Well, 6 does nothing here. 6 does, they're factors of 48. So my denominators, let's see if we can fit that in here. Denominators are factors of, let's see if we can get in here, leading coefficient. So we're going to write that down here. So zeros, here we are. We'll write it as a fraction. The numerators are factors of constant, and the denominators, I'm just going to show by writing it, are factors of leading coefficient. We're almost done with this. Literally, this one step is going to get us through the vast majority of what we're doing. So, if you use the zeros, you can write this in factored form. Right? So if I use the zeros that you see up here, we can write this in factored form, right? Because a factor is just the opposite of the zero, one placement. It's x minus the factor is what we're writing. So somehow these are the same as these. Let's talk about this guy up here. Here's my original equation. And since I got these factors, if I put x minus in front of them, so negative 3/2 would turn into x plus 3/2. Somehow these are the same. In fact, if I set any of these equal to 0, so let's play with this 2/3. So a factor of 2x plus 3 becomes a root of negative 3/2. We can show you that. We could say 2x plus 3 equals 0, subtract 3. 2x equals negative 3, divide by 2. Right? And the root, we'll say this, a root, some capitals, of negative 3/2 becomes a factor of x minus negative 3/2 or x plus 3/2. So they're basically the same thing. And we could write that in kind of a standard form, right? We could say, in general, if I have a 0 of negative b over a, it equals ax plus b. So 0 of negative b over a equals ax plus b. And there it is. So there's the basic notes. We're going to go kind of step by step and show you how this works when we do it. But we're done with page 1.